In this tutorial, we'd like to show you how in just a quick few steps you can train new AI models for use in our plane picking service. Our plane picking service lets you recognize and localize items that are randomly distributed on a planar surface. The plane picking service is described in more detail in our documentation, and you'll also find a short video down here below that shows the service in action. What you'll see here is that the service is not just able to localize objects, but also classify them. That is, distinguish different object types from each other. This information is, of course, passed back to the robot controller so that it can execute a specific action for each object type. However, to keep things simple, we're going to focus on a single object class in this tutorial. To be able to start the training, you will need three things. First, a CAD model of the gripper that will later be attached to the flanger of your robot, a CAD model of the object you wish to train, and finally, a calibration image. So let's start with the CAD model of the gripper, which I've opened in MeshLab here, a software that you can download for free from the internet. Please make sure that you export the model from your CAD system in the OBJ format. Also, it's crucial that the intrinsic coordinate system of the model matches the one in orientation and location that you will later enter as the TCP coordinate system on your robot. So in this example, the origin of the desired TCP coordinate system sits right between the two fingertips. Next, as we would expect, the z-axis of the desired TCP coordinate system is parallel to the gripper fingers. The x-axis is parallel to the direction of motion of the two fingers. And of course, the y-axis is orthogonal to both previous axes. So next, we want to upload this CAD model to our cloud backend, and for that, we open a new browser tab and then navigate to the site www.vatas.vision. So let's log in and switch to the tab Grippers down here. Click on New Gripper. And first, we have to assign a name, so let's call this one Demo here. Next, we pick the gripper type, two-finger in this case. Now, it's really important to check the unit in which the model was exported from the CAD system here. Typically, models are exported from CAD systems in the unit millimeter, but if that's not the case, then please make the right selection here. And finally, we pick the actual model from the file system, attach it to the form, and click on Save and Exit to start the upload. Next up is the upload of the CAD model of the object. And for that, switch to the Products tab down here below, click on New Product, and select the workflow plane picking. So again, we first need to choose a name for the product, and I brought some sort of screw here as an example today. Also, we need to assign the product to a customer. It's also important to pick the model of the camera which we are using to take images of the object. So in this case, a Ziva 2. Then, as we've seen before in the upload of the gripper, the unit of the CAD model. Again, in most cases, we should be fine with the default setting of millimeter here. Then attach the actual file. Again, this must be a triangulated mesh model in the OBJ format. But other than that, there are no special requirements on the model, such as in the case of the CAD model of the gripper. Now let's assign the gripper that we've just created a minute ago. Click Save. And then finally, we start the upload of the model by clicking on Save and Exit. The third and final ingredient for the training that is still missing is the calibration image. And to record that, we go back and connect our laptop to the robot cell. The calibration image is taken of the flat surface that the parts rest upon during the process. For example, a conveyor belt or the top of a pallet. To trigger the acquisition of the calibration image, we'll open up the 3D Viewer app in the browser, much like in tutorial number 1 on network setup. You can reach that app under the IP of the edge device within the machine network. Here, simply click on the yellow capture button, and we'll immediately see a 3D visualization of the point cloud that we just captured of the underground. To finally start the training, we switch to the Trainings tab in our web application. Then click on Start Training in the upper left. This shows yet another dialog in which we first pick the product that we wish to train, so the screw in this example, then the device to which the result of the training will be transferred upon completion. So we have only one choice here, the device named Tutorials. The plane picking workflow is already selected by default. That's pretty convenient. The last step is selecting the calibration image that we've just recorded, and it got synced into our cloud backend. So finally, we click on Save and Exit. There will be a short reminder that the training will incur cost, but after acknowledging that, the training is finally underway.